All right, so let's say you're asked the concavity of a function. The concavity, if you remember, is the second derivative. So you can do that by actually calculating the derivative, then taking the second derivative. But here you have to use chain rule in this one, and you have to take two derivatives, and it's exhausting. Let's show how to do that in your calculator really quickly. So you have to know that concavity means second derivative if they ask that. But we're taking the second derivative at the value x equals pi. So if you remember from before, the derivative function in your calculator is math 8. So we're going to put the x down here, and of course we eventually want to take the derivative at x equals pi. But here's the thing: we want the second derivative. So we want the derivative of, instead of this function, instead of putting the function in there, I'm going to put math 8. I'm going to do derivative of the derivative of this function, and then I'll show you how we'll figure out how to put these in here. So I'm going to put the function 3 sine of x plus 4, and they actually wrote this a way that I usually don't see. You will probably see it in other forms, cosine squared x. So here they wrote it the way you have to put it in your calculator, but you're probably going to see it as cosine squared, not cosine of x and the whole quantity in parentheses squared, but you would have to lead with parentheses, put cosine of x, close the parentheses, then close the parentheses in front of the cosine, then take that and then square that. And here's where we got to figure out what to do here. So we want the second derivative at x is equal to pi, right? So we want it to be at x equals pi. So what do we put here? Well, to get this x to read this as x and then to go to this x, you'll probably have to put x, and then instead of putting pi here, you'll have to go and put an x here. So let's see what happens when we punch that in. And notice again, your calculator kind of does, it does sort of a left and right average rule, but the answer will be -8. And just to show you, here's what you don't want to do. You should get an error. If I were to type pi right here, the calculator should get mad at me. Oh yeah, just get 0. Yeah, so in other words, if you evaluate this and you evaluate this at pi, you get a constant. If you take the derivative of a constant, you get 0. So that's why you don't want to put, you only want to put pi at the end because you were taking the second derivative at pi. So you have to put, when you're taking second derivative, again, you do derivative of derivative. And you can do it by hand using chain rule and take this, derivative of derivative and then plug pi in. And one thing you need to make sure of, in calculus, keep your calculator pretty much always in radian mode. So right now, put your calculator in radian mode. All right, say you want to find where, be careful because they don't ask you to find the maximum value. They want you to find where the x value is. You can find the derivative, and you can like take critical points, like the derivative of this would be 3x squared, blah, blah, blah. Take that derivative, set it equal to 0, and you can find your critical points. And here's the thing, out of those critical points, you don't know which one's a min, which one's a max. You got to use the first or second derivative test. But you want to find the maximum of a function or where it has a maximum, again, just graph it in your calculator. So inside of our y equals, we're going to put this. So I'll put x cubed, and just a reminder to do cubed, you do the little caret. X cubed minus 9x squared plus 24x plus 4. All right, and let's hope the zoom standard window works for us. It doesn't always, but I hope it does. Oof, gosh, it's pretty gross. So the downside between using your graphing calculator instead of using your using this is like, oh, we have to find the right graph. But guess what? This is a multiple choice test. So I'm actually going to go to my table, okay? And I'm not even going to use my graph. I'm just going to look and see which one of these has the highest x value. Let's start with -4. All right, -300 is the number to beat. I'm guessing I'm going to beat that. All right, at -2, we get a -80, a -88. So yeah, we beat it. The next choice looks like +2. That maps to a 24. The next choice is +3. Ooh, it's actually less. So far, the x to beat is 22. Remember, you're looking for the x value. They're not asking you the max. So something they could do is put 24 as an option, but it's the right answer to the wrong question. So far, 2 is the number to beat, but I still need to check 4. Hey, 4 maps with 20 as well, so the answer is 2. And all I did for that was I went to my y equals, I put the function in there, I went to my table by hitting second graph, and then I just checked the values. That's all I did. Now, instead of scrolling through, another option you can do is go to second table, which I second window, go to ask, and now I can see just the values I care about. The values I care about were 4, -2, 2, -4, and 3. And you can see again the one who has the highest y value is 2. So, and this is by doing that second table set thing. So the best method, instead of even using a graph and worry about the window, is a multiple choice test. Exploit that, put it in there, and check the values. This is using the auto-generated feature in the independent variable. This is switching the independent variable to ask to make it a little quicker. Okay, next we're going to do average value of a function. When you study definite integrals, you learn that the rule for average value of a function from a to b is you integrate that function from a to b, and then you divide by b minus a. Or you may have seen the formula like this. This is the same thing as 1 over b minus a equals times, and then you just write that integral like so. Now they use g of x, so but I don't care. I'm not going to write g anything. I'm going to take the average value. So I'm going to do this. I'm going to take the average value from -3, because that's a lower number, to -1 of this function. I'm going to put this function inside of an integral, and I'm going to divide by -1. That's the b minus -3. I can do all of this in my calculator instead of doing it by hand. So math 8 is derivative, but if you remember, and you can scroll through to check, but math and then hitting option 9 is the integral. So I'm going to enter the limits of integration here, -3, oops, it does not like what I did there. -3, -1, it doesn't like me hitting enter, you have to hit the side arrow. Then put the function in there. So you notice that these parentheses are for the function, so I have to insert another set of parentheses. Then do 2x plus 3, close those parentheses, and then raise that to the second power by doing caret 2, or I could use the second power button, and then dx. And I could do this all in one line, but I'm just going to just hit enter prematurely. Then I'm going to take that answer and divide. So, oops, I'm gonna hit the division key. It's gonna take this answer. It's gonna divide it by the b minus the a. The b being -1. Subtract -3 from -1, and I get 2.3 repeating. I'm gonna hope that this converts that to a fraction. Sometimes it doesn't, but yay, it did. Like sometimes, again, because your calculator kind of estimates these integrals, it will refuse to turn it into a fraction, but you know that that's 2 1/3. So you should know that, 3 times 2 is 6. At 1, you get 7/3. So your answer for the average value of that function is 7/3.